Welcome. Today we are going to be looking at some other mechanisms for evolution. Earlier we looked at natural selection as a mechanism for evolution, and today we're going to be looking at two other mechanisms that cause an allelic shift. The first of which is genetic drift. Genetic drift causing an allelic change is one of the mechanisms for evolution that we will look at today, and the second is sexual selection. And by the end of today, you should be able to compare and contrast the three different mechanisms for evolution. You should be able to compare and contrast genetic drift, sexual selection, and natural selection, and how they all are mechanisms for evolution. In other words, how they all result in an allelic frequency change. First, we're going to look at genetic drift. And in genetic drift, what you see is that the allelic frequency doesn't necessarily change based upon fitness or success of a specific individual or population. It ends up being a result of the population migrating or of some very, very large natural disaster which wipes out a large portion of the population. The two different ways that genetic drift occurs we call the founder effect or a population bottleneck. Let's look at these. With the founder effect, you see that we have a small group is going to leave our large population. And when that small group leaves a large population, it's going to leave with whatever alleles it has. The chances of that small group that's leaving the main population having the same allelic frequency as a population is relatively low. And so, when the small group leaves a new population and reproduces, it ends up reproducing to the allelic frequency of what the original small group had. It's independent of the main population that they had left. And so you have an allelic shift based upon the individuals that had left that population and formed a brand new grouping somewhere else. An example of this could be with foxes, where we have black-tailed foxes and white-tailed foxes. In this population, we notice that the vast majority of them all have black tails. Only two have the white tail. But if two of these foxes left the population and then reproduced to form a brand new population, now their frequency of alleles is completely different from the original population. Another way that this can occur is instead of a group leaving a population, we can have what's referred to as a population bottleneck. In a population bottleneck, instead of a group leaving, we have the main population dying. It declines rapidly due to some very large disaster. So this could be an asteroid coming in and hitting the Earth, or this could end up being an ice age that occurs. Something happens that makes a population drastically decline. There are many different reasons for this, but the population ends up rebounding. It doesn't go extinct, but it is able to recover. But allelically, it isn't quite as nice as just a population numbers game. You see, in the original population, there was all these different alleles, and so we had all this variation in our original population. But then, when the tragedy struck, the vast majority of those variations were wiped out. We are left with a population that doesn't have very much variation. We have a population that is almost every individual identical to each other. And we've seen this happen. Basically, one of the most well-known examples is with the cheetah. About 10,000 to 12,000 years ago, the cheetah population declined rapidly. And then, without going extinct, they recovered over time. And the issue that we have today is that cheetahs, no matter where they are so closely related to each other that they are almost identical. This is all due to inbreeding, but that was the only way for that population to continue. So cheetahs don't have much variation amongst their population because of the massive decline of their numbers and then the recovery. But there hasn't been enough time for mutations to occur between the different cheetahs, so they end up being very, very, very similar. They don't have a lot of alleles change because they haven't had enough time for that new variation to come about. The next mechanism for evolution is sexual selection, and this is where mates have a choice. There is a preference for a specific trait that they are looking for in the mate. This could be seen in lions, where typically the male lions will fight over being in control of a pride. This could also be seen in peacocks, where the female, the peahen, chooses the males with the largest tail, the largest train, and the most color in that train. It could also be seen in frogs, where typically the females will choose the male that sings with the lowest tone or the loudest tone. Based upon that mate choice, based upon one individual in the population choosing their mate to then have offspring with, that means that that trait that they were looking for is typically passed on to the offspring. That trait will then continue on and on and on, and other alleles that are not favored by the mate are going to disappear because that individual will not mate and will not have offspring, and thus those traits that it possessed will not be passed on. This is a cause for sexual dimorphism because the mates are typically looking for different things. Sexual dimorphism is where the male and the female of a specific species appear different. There are different traits for the male and there are different traits for the female that have been passed on by generation to generation to generation because those traits have been favored. So in conclusion, what we have is that there are many ways that the allelic frequency can change. It can change based upon simple competition for resources, natural resources that exist. It can be based upon the migration patterns of the different populations. It can be based upon a tragic disaster that destroys a large portion of a population, or it can be based upon sexual selection, where the mates choose which traits or which alleles should be passed on and which alleles shouldn't be passed on. Each aspect helps cause for certain alleles to be favored and other alleles to disappear. The favored alleles continue on, and that causes over time an allelic shift where the favored alleles will stay around in the population and the disfavored alleles will disappear. The favored alleles will be successful and the unfavored alleles will not be. Each of these is a mechanism that causes allelic frequency change. And because of that, each of them is a mechanism for evolution. That's it for this time. Be awesome, stay awesome.